Dear students and viewers, today let us discuss about some fundamentals of quadratic equation. Let me take a function y equal to f of x, where f of x is given by ax squared plus bx plus c. So this is called as a quadratic equation because it is having the power to be 2. Whenever we have the power to be 2, it is called as quadratic equation. Which means here a should not be equal to 0. If a becomes 0 means this entire term will vanish. So it can't be a quadratic equation. So for a quadratic equation, a cannot be 0. So your question may be whether a can be less than 0. Yes, it is possible. Whether there is a possibility whether a can be less than 0, minus 1, minus 2, yeah, it's acceptable. Whether a can be greater than 0, that is also possible. That is also possible. So the only condition is that a should not be equal to 0. Let me put in another way. If in the same equation, if a is equal to 0, then what happened to y? Y will become bx plus c. So now the equation is not quadratic, it becomes linear. It becomes what? Linear. This is the equation of a straight line. This is the equation of a straight line. So from this equation, what we understood is that a cannot be 0. If a becomes 0, the quadratic equation becomes linear. It becomes a straight line. So that is the first condition. And there are two conditions where a can be less than 0 as well as a can be greater than 0. This equation is called as quadratic equation. And here the y variable is called as the dependent variable. Y is called as the dependent variable and x is called as independent variable. The x can take any value. X can take any value. Okay, based on the value of x, the corresponding value you will get for y. So that only we are telling y is a function of x. Y depends on x and hence y is called as dependent variable and x is called as independent variable. And so general convention to draw the dependent variable along the y-axis and the independent variable along the x-axis. In any case, in any particular case, generally we should draw the along the y-axis the dependent variable and along the x-axis we will use to draw the this independent variable. For example, for engineering application, especially for the mechanical engineers, we should draw the PV diagram. Pressure versus volume. This is not a velocity. This is specific volume. So it is volume. So if it goes on increasing the volume, then my pressure will drop. Then my pressure will, this pressure curve will drop. So we see that pressure is a dependent variable on volume. Pressure is a dependent variable on volume. So actually we should draw the dependent variable along the x-axis and the corresponding, the independent variable along the x-axis and the dependent variable along the y-axis. That's fine. This is not related directly to our study over the quadratic equation today. This is for general application. Now, this quadratic equation, what is the shape? If it's a straight line, I know the shape will be what? This is the straight line. Or this can be a straight line. Or this can also be a straight line. For example, if I am going to draw the xy here. Now the straight line is parallel to the x-axis, that is horizontal. Here the straight line is what? Parallel to the y-axis. Or the straight line can also be inclined. This is also straight line only. This is also a straight line, but it's an inclined line. But it's an inclined line. Here the inclination is not there. Here is a vertical line. Here is a, let me call this as 1 to 2. Let me call here this as what? 1 to 2. Let me call this as what? States 1 to 2. It's moving from state 1 to 2. Okay. So here this is a straight line. We know that this equation is given by what? Y equal to mx plus c. In this case, y equal to what? Bx plus c. If I am going to make a equal to 0, then the equation will reduce to straight line. So y equal to bx plus c. So now this equation indicates the equation of a straight line. Similarly, I am asking, what will be the shape of a quadratic equation? When it's going to be a equation like this, it indicates a straight line. Whether it can be horizontal or vertical or it can be inclined. Similarly, what does this equation will represent? Atul, you already know the answer. Huh? Yeah. So please, viewers, try to understand the shape of a quadratic equation is always a parabola. is always a parabola. And you know the shape of a parabola, isn't it? Let me draw a, it is x-axis, it is y-axis. Let me draw a parabola. Okay, that's fine. Now, this is the shape of the parabola, and whenever a is greater than 0, this parabola is, this is the shape of the parabola. This is the shape of the parabola, which can be given as what? F of x equal to ax square plus bx plus c. Depending on the value of a, b, c and x, the shape will vary. The shape will vary, but the shape will be always a parabola. And now, when a is greater than 0, the shape will be always open upwards. The shape will be always what? Open. Now it's going upwards only. Hence, whether we'll be able to obtain the minimum value from the graph or the maximum value. Minimum. Which is the minimum value? The point where the two axes will meet, where the two symmetry lines will meet. It's not the symmetry line. This is also same. This is also what? Same. If I'm going to place a mirror here, I'll get the mirror image of this one. I'll get the mirror image of that. Symmetry will be there. Symmetry will be there. And the minimum value will be here. So we'll get the minimum value. We'll get the what? Minimum value when A is greater than 0. When A is greater than 0. What is the maximum value? It is infinite. This graph will go like this, like this, like this, like this. It keeps on going, and we are unable to find it where it is. So it's infinite. So we will be unable to find the maximum value, but it's possible to find out the minimum value because A is greater than 0. Because A is greater than 0, we'll come to this condition of this. How we arrived it, we'll come to that later. But whenever the value of A is greater than 0, we'll end up with a minimum value. Okay, fine. On the other hand, the same graph, now what is the value of A? For the green color graph, it's also a quadratic equation. This is also a parabola. Now what is the value of A? A is less than 0. So whenever A is less than 0, what is the value we'll get it? Whether it's minimum or maximum? Is maximum. Why? It is 0. It is 1, 2, 3. It is minus 1. It is say, it is minus 1. It is say minus 2. Here minus 3. Isn't it? Minus 4 like that. Okay, minus 1 like this. Now what I'm telling means, this is the maximum value I can get. The minimum value, because minus 4 is less than minus 2. So when goes, this curve is going downwards. So it's called as open downwards. This is called as what? When A is less than 0, it is called as open downwards. And what is the value we'll get? I'll get the maximum value, not minimal. This is called as what? This vertex will give me the maximum value. What about this line? This line is called as what? Axis of symmetry. This line is called as what? Axis, because I can see a similar graph on either side. So this line is called as what? Axis of symmetry. Then you may have a doubt whether the axis of symmetry will always be y-axis. Then you may have a doubt whether the axis of symmetry will be always a y-axis. It need not to be. Now you come to know what is the importance of A is less than 0. Less than 0 means maximum value you will get, and the curve will be down, open downwards. When A is greater than 0, the curve will be open upwards, that will get the minimum value. Now your doubt is, the parabola shape is symmetry. The parabola shape is symmetry about a particular point. That particular point is called as vertex. That particular point is called as what? Vertex. Now, the question is whether the symmetry should be always the y-axis. Need not to be. Now you see here. Now what is my vertex? This is my vertex. Because with respect to this point, I will have symmetry shape on either side. And through this point, if I am going to draw a line, this line is called as what? Axis of symmetry. Axis of symmetry. Got the logic what I am telling? So you will get, so the symmetry, axis of symmetry always need not to be in y-axis. It can be anywhere. It can be anywhere. Now there may be a question. What is the question? Why the graph should be always either upwards or downwards? It can be right or left. Yeah, you are right. It can be either, it can also be in the right or left direction. Good. So what is the graph you expect? It can be like this, isn't it? It is x, it is y. It can also be in this direction like this, isn't it? Now the graph will not be y equal to f of x. Now the graph will be equal to x equal to what? F of y. Then the value will be equal to what? Now x depends upon y. Now x becomes the dependent variable, y becomes the independent variable. Now the graph will be, instead of a into x squared, it will be called as what? A into y squared plus b into y plus c. Got the logic? If a is greater than 0, then I will get this value, minimum value only. Okay, if a is less than 0, maximum value. And a equal to 0, straight line. It becomes a straight line. So the parabola can be either open upwards or open downwards or open, what we can say, rightwards or open leftwards. Okay. So I hope you got the entire idea about a parabola. From this, at least we can gain the knowledge that the shape of this quadratic equation will be parabola. A parabola is a shape which have two symmetrical images, two mirror images, where they converge at a point. That point is called as vertex. That point is called as what? Vertex. And the line which makes equal parts is called as axis of symmetry. Is called as what? Axis of symmetry. So now we came to know what is axis of symmetry, what is vertex, what is the shape of the quadratic equation, how it can be, and where you can get the minimum value and where you can get the maximum value. Okay, fine. Now let us confine ourselves to what? Only y along the y-axis and x along the x-axis, or y is the dependent variable and x is the independent variable. Okay, fine. Let me track a graph. Let me try to draw a graph. So it's not that much good. Okay. Okay. So this is the x-axis. This is the y-axis. Okay. Now, in this graph, I want to find the slope of this parabola. I want to find the slope. Slope of, what is the slope of parabola? Slope of the quadratic equation. Slope of the quadratic equation is nothing but what? Slope of the parabola. In case of straight line, before going to quadratic equation, let me take the simplest one. Now this is the straight line, which is parallel to the x-axis, which is horizontal line. Now what is the slope? 0. Now slope equal to what? 0. What is the equation of a straight line? We know that the equation of straight line equal to what? Y equal to mx plus c, where m is called as your slope of the straight line. Slope of the straight line. Okay. Now, in this case, m equal to 0. In this case, what? M equal to 0. Then y equal to what? Constant. So now this horizontal line indicates, let us say that c is 5. Okay, so it is 0, it is what? 5. So now y equal to 5 means it indicates a horizontal line of x equal to what? It starts from 0 and goes up to infinity. But always my y will be what? 5. Y will be always what? Positive 5. Y will be always positive 5. This line doesn't have any slope. This line doesn't have any slope. Now, I will draw another line. Instead of this line, I will draw a line like this. Let us say this line starts at 1 and ends at what? 2. Now whether this line has slope or not? Yes. What is slope? Huh? So how we can tell? Very good, very good. So you already know the concept, so you are telling very clearly and keenly. Now this point 1 is called as x1 comma y1. This point 1 is called as what? x1 comma y1, because we consider this point as what? x1. This point is what? y1. This point is what? x2. This point is what? This point is what? y2. So 1 corresponds to x1, y1, 2 corresponds to x2, y2. So for example, whenever we used to climb some steps, so we call this is our slope. This is our slope because we have to step up. Sometimes we feel more difficult if the slope is more. So instead of like this, if I'm going to have like this and like this, then I have to climb like this. From this step, got it? From this step, I have to climb up to this path. Or from here to here, I have to climb. From here to here, I have to climb. So here you can see the slope is more compared to here. Compared to case number 1, let's take compared 1 and 2. Here the slope is less. Here the slope is more. So how we are able to determine means the formula for slope is rise by run. Rise by what? Run. Rise means vertical direction. Run means horizontal direction. So which means what you told is right. Which means what is the rise? It is y2 minus y1. y2 minus y1. What is run? x2 minus x1. So x2 minus x1. So if y2 minus y1 is more than x2 minus x1, the slope will be more. Not the logic. So the like to for the case 1, my slope is lesser, whereas for case 2, my slope is more. Because here y2 minus y1 is more compared to x2 minus x1. So the formula is run by rise. Run by rise. Okay, fine. So in this case also, I want to find what is slope. Slope equal to, as Atul told, it is y2 minus y1 by x2 minus x1. Now what is y? Y is nothing but a function of x. Here also, I am first talking about straight line. Y is also a function of x. So what will be the coordinate at 1? It is x1 comma f of x1. Can I tell like that? x1 comma f of x1. Why? Because y equal to f of x. So if I go for 1, I will get y1. y1 equal to f of x1. Similarly, what is y2? Oh, sorry, this coordinate, second coordinate is what? x2 comma f of x2. f of x2 is nothing but y2. f of x2 is nothing but y2. f of x1 is nothing but what? y1. Okay. Now, so I will write like this. I will take a midpoint. This point is called as at x equal to x naught. X equal to what? X naught. I will draw a vertical line. So this point is what? X equal to x naught. And x2 is nothing but x plus h or x naught plus h. So x2 is nothing but what? X naught plus h. I am taking an equal point of the other direction. Even though in the board is not equal, you imagine it is equal. Okay, this h is also equal to this h. So what will be my x1? What? No, with respect to x or x naught. Very good. X naught minus h. With respect to this point, it will be 2h. I agree. But we are seeing with respect to the middle point. Then only I will know the slope. Okay, so I will repeat once again. The coordinates at x2 is nothing but x naught plus h. Because this distance is x naught. Plus h will be x naught plus h. This distance will be what? X naught minus h will give me the coordinate here. So I know what is x1 or I know what is x2. So here I can put what is y2 then? Y2 will be equal to f of x naught plus h. What I had write? I had write f of x2. What is f of x2? X naught plus h minus f of what is y1? F of x1. What is x1? X naught minus h. F of x naught minus h by my x2 minus what is x2? x2 is nothing but what? X naught plus h. x2 is nothing but what? X naught plus h. What is x1? x1 is x naught minus h. I hope you understood it. Okay, so the coordinates corresponding to x2 is x naught plus h. The coordinates corresponding to x1 is what? X naught minus h. The corresponding coordinates of y1 and y2 are nothing but function of what? The corresponding x coordinates. So it is f of x naught plus h minus f of x naught minus h by these values. Now what will happen to the denominator? Denominator will reduce to what? Very good. It will reduce to 2h. How? Simple only. X naught plus h minus x naught minus h. Minus of minus h will become what? Plus h. So h plus h will become 2h. So the denominator will become 2h. What is the numerator? F of x naught plus h minus f of x naught minus h. Okay. What is this function? Y equal to f of x is mx plus c. Now what is f of x naught plus h? Which means the function is mx plus c. So it is m of, wherever x is there, you try to replace with x naught plus h. So it is x naught plus h, isn't it? Plus c. You see, the function is mx plus c. So I tried mx plus c only. But wherever x is there, you put as what? X naught plus h. Okay. Minus. So we have completed this term now. We have completed this term. Coming over here, what I write now is also a function of x. So this is a function of x. So wherever x is there, what we replace? X naught minus h, because we are going to the other coordinate. So it is what? M into x naught minus h plus c. So better you put a bracket over here. Or even you can remove this one. But yeah, better to put. Okay. The denominator is not a problem. 2h. So from this, what is the value? M into x naught. I am multiplying plus m into h plus c minus m into x naught minus plus minus into minus will become plus m into h minus c by 2h. So m into x naught minus m into x naught get cancelled. C minus c. So it become what? 2mh by 2h. So 2 get cancelled, hh get cancelled. So slope of x at x0 at x naught is equal to what? M. So that only we are telling this m is nothing but the slope of the straight line. This the, even though we started with quadratic equation, but finally we ended with what? The slope of the straight line, which is nothing but what? M. Which is nothing but what? M. So if I am going to have a straight line like this, horizontal line, now my slope is what? 0. Because there is no rise. So my m will become 0. Then in this equation, Atul, can you tell me what will be the value of, what is the m should not be? What should be the value of m should not be? You told here in this equation a should not be what? Equal to 0. Here what should be the value of m should not be? Or I will put in other way. So you feel difficult. So now this is nothing but what? My slope. The slope is there because the inclined line. Because there's an inclined line, definitely there's a rise, there's a run. So there's an inclination is there. One more formula for slope is tan theta. Okay, which is theta? The angle, this line, straight line, makes it the horizontal. Measured in the anti-clockwise direction. Measured in the anti-clockwise direction is called as what? Theta. Now the slope m is equal to what? Tan theta. Got the logic? If it is tan 45 some value, tan 30 some value, tan 0 is 0. Tan 0 is what? Because the angle is 0 means 0. So the slope is also given by a formula called as what? Tan theta. But here we can measure only theta. From that you have to calculate tan theta. What is theta? The inclination of the line of the given straight line with the horizontal. With the horizontal measured in the anti-clockwise direction. You should not measure like this in the clockwise direction. You should not. It should be measured in the anti-clockwise direction. That's fine. Now, keeping in this mind, now you draw a vertical line. Now, what is the angle? 90 degree. So, what is tan 90? Infinity, undefined. So, the line which is vertical, we are not considering here. A line which is vertical, we are not considering here, or we are not considering the theta equal to 90 degree. Theta equal to not 90 degree. So, here we are not confining m to be what? M correspond to theta equal to 90 degree. The other lines we are considering. The other lines we are considering in a straight line. Okay, that's fine. So, even though it's quadratic, we went deeper into what? The slope of a straight line. The slope of a straight line is a constant. The slope of a straight line is a constant. Whereas the slope of a parabola is not a constant. It's not a, that's what we are going to see. That's what we are going to see. So let us now come to our main picture. This is our main picture. Picture is a quadratic equation. Okay. Every time I draw a different graph, but still it's a parabola. We assume it's a parabola, even though it doesn't look like that. Okay. So this point is nothing but my vertex. And this is nothing but my axis of symmetry. This is nothing but what? My axis of symmetry. Okay. Now, Let us consider this point as what? X naught. So this point is what? The point 2, which is nothing but what? X naught plus h. This is nothing but what? My x naught. You take a similar point on the left hand side. So let us call this point as what? 1. And this point is what? X naught minus h. Similar to the straight line, here also I am considering 3 points. The first point is the middle point, x naught, and the other point is point number 2, where it is given by x naught plus h. So the distance between x naught and x naught plus h is h. Similarly, the distance between x naught and x naught minus h is also what? H. But it's coming in the negative direction, but it's coming in the left hand side. Okay, so we have these 3 points. We have these 3 points. What is the slope? What is slope? Here also same formula. y2 minus y1 by x2 minus x1. Okay. Here also we are finding the slope at x equal to x naught. We are trying to find the slope at what? In the straight line also we found the slope at x equal to x naught. Here also we are trying to find the slope at x equal to x naught, which is nothing but y2 minus y1 by x2 minus x1. What is y? Y equal to f of x. Y is a variable which depends upon x, a function of x. What is the function here? Yeah, very good. It is not mx plus c. Here the equation is what? Ax square plus bx plus c. Here the equation is what? Ax square plus bx plus c. Now, what is the product of my 2? 2 is what? x2 comma y2. What is x2? x naught plus h. What is y2? F of x naught plus h. What is the logic? The coordinate at point 2 is x2 comma y2. But what is the value of x2? X naught plus h. So we know x naught plus h. What is the value of y? Then f of x naught plus h. Now let us come to point number 1. What are the coordinates? x1 comma y1. What is x1? Very good. X naught minus h. What will be y1? Very good. F of x naught minus h. So this is x1 y1. This is what? x2 y2. Let us try to go here. Let us try to implement 2 y2 minus y1 by x2 minus x1. What is y2? y2 is nothing but f of x naught plus h. The same thing what you derive for straight line. Minus f of x naught minus h. Divided by what is x2? x naught plus h. What is x1? x naught minus h. So what will happen? X naught will get cancelled. This minus of minus h will become plus h. So denominator will be 2h. Denominator will be what? 2h. Can you help me with the numerator? Or you will write that. So it will be easy. So I hope here the diagram is not required. Yeah, the denominator is 2h. What is the numerator? Can you help me? If wherever x is coming, you have to replace with what? X naught plus h. Whenever I am going to write here, wherever x is there, I have to replace with what? Please, can you help me now? Yeah, tell me. A into. No. There is one big mistake. Yeah, you tell me. X naught squared. Yeah, instead of that, we can put like this. Wherever x is there, you replace with what? X naught plus h whole square. Then in the next step, we'll expand. Since you are brilliant, you are telling the same step, but everybody cannot understand. So, wherever x is there, you try to replace with what? X naught plus h. So, this square is also there. Plus b into x naught plus h. Plus c. There's no x, so there's no need to replace. Minus. This is the first term. This value is equal to this value. Minus. What will be the f of x naught minus h? Wherever in this equation x is there, you replace with what? X naught minus h. So it's minus, I'll put a bracket, a into what? X naught minus h whole square plus b into x naught minus h plus c. Isn't it? I know the denominator is what? 2h. Denominator is 2h. So as you told now, we can expand it. So it is a into x naught squared plus h squared plus 2 into x naught h, because you know the reason. A plus b whole squared equal to a squared plus b squared plus 2ab. That's the reason we have expanded. Okay. Plus b into x naught plus b into h plus c. Isn't it? Even we will try to multiply this a to all the terms. Let us do in the same step. So this a is common to all the three terms, isn't it? So it is like this I am telling. So I will not do in two steps. So this a, when I multiply it to all three terms, it becomes a into x naught squared. It is a into x squared plus 2a x naught h. 2a x naught h. I have taken a and a inside the bracket minus this one I will put minus a of I will put the bracket x naught squared plus h squared minus 2x naught h. This is nothing but what? A minus b whole square equal to a squared plus b squared minus 2ab plus b into x naught minus bh plus c whole divided by this entire term divided by what? 2h. This is the denominator. That's what I used to tell is a denominator. So let us multiply this a also inside for all the three terms. This term, this term, this term, all these three terms have a. Okay, so I will put a here also what? A here also what? A, because the a is common for all the three terms. Okay. Now what happens? We can strike off a x naught squared as well as what? Minus a x naught squared. This minus is common to all the terms. Otherwise I will repeat one more step, I will do it. Nothing wrong. A into x naught squared plus a h squared plus 2a x naught h plus b x naught plus bh plus c minus, I am taking this minus to all the terms, minus a into x naught squared minus a into h squared plus 2a x naught h minus bx naught plus bh plus, sorry, it will become minus. Whereas positive you put negative, whereas negative you put positive. That's it. By denominator is 2h. So whichever terms we can cancel off. Ax naught squared minus ax naught squared. Ax squared minus ax squared. This can't be cancelled, both are positive. Bx naught, yeah, minus bx naught. Bh, that's also bh. C. So now what is the final form? We have entered with 2a x naught h, here also 2a x naught h. So it's 4. 2 pen plus 2 pen is 4 pen. So it is similar to that. So it is 4a x naught h. Then plus 2bh by 2h. Okay, I hope I can erase these things. Okay. So in the numerator, which can be taken common?
2h.
Yeah, 2h can, very good. 2h can be taken common. So it become 2a into x naught. If I multiply it become 4ah x naught. Okay. Plus b. Divided by, so 2 cancel, h cancel. So the slope of the given quadratic equation of the parabola at x equal to x naught is given by what? 2a x naught plus b. To x naught plus b. So here we see that this slope is not a constant, it keeps on varying. As x varies, this x is at x naught. But if x is not at x naught, it is going to be x1, it will have a different value. I will recall the diagram. This is the diagram we have drawn. Here I told x equal to what? X naught. Here I told what? X equal to x2. Here I told what? X equal to x corresponding, I am taking the x coordinates. Okay. So at this point only the slope is this one. But this point, at this point the slope depends upon what? The corresponding x coordinate. Not only that, it depends upon the coefficient of x squared. It also depends upon the coefficient of what? X. It also depends upon the coefficient of x. Now my question is, if this b is 0, then what does your equation will become? It becomes 2a x naught. It becomes what? 2a x naught. What? A is some constant. Let us assume it is positive or negative, but a is a constant. 2 is also constant. So what is x naught?
Varies.
No, that varies. But the slope at a particular point I am asking. What is x naught? It is going to be a particular value for x. It is going to be either this value or this value or this value. Isn't it? This is the slope. This is the corresponding slope that we are telling. So it remains constant. It will remain constant, or when the b becomes 0, this value tends to reduce to, definitely as you told, is not going to be constant. It will depends upon the location of x. Okay, the corresponding x location. So finally what you are telling means the slope of a given quadratic equation is given by 2a x naught plus b. If we are going to measure at x naught, or you can keep it as what? 2ax plus b, where x is any variable. X is the variable along the x-axis. Okay. So if you are not happy, I will put as 2ax plus b. This is also fine. Now, this is a function of what? X. So let us call the slope as a function of x. Now we are happy now. Now slope is a function of x. In case of a straight line, it's not a function of anything. M is not a function of, it's just a run by rise. It's a constant. But here it keep on varying. So what is the inference we got from this exercise today is that the slope of a quadratic equation or the slope of a parabola is not a constant. It keeps on varying. It keeps on changing as per the location of your x. It will always be tangent to the particular point. It will always be tangent to the particular point in the, then only it becomes tan theta. Then it will become what? Tan theta. So that is a thing what we have derived. So today, to summarize, we can tell we have seen the shape of a quadratic equation as parabola. It has always exhibit a symmetry nature with respect to the left hand side and the right hand side. Where these two curves come and join, it is called as vertex, and a line which is passing vertical through this is called as axis of symmetry. And this equation, the value of a cannot be 0, otherwise it becomes straight line. If a is greater than 0, it is open upwards and you get the minimum value. When a is less than 0, it will open downwards and you get the maximum value. And you get the maximum value. In the next class, we will discuss some problems related to this basic equation, the slope, the vertex. So you may be asking a question, what is the usage of finding the slope? What is the usage of finding the vertex? What is the usage of the axis of symmetry? What is the usage of minimum value and what is the usage of maximum value? All these things, let us take some practical problems and we will solve. Then you will know the importance of a quadratic equation. I hope it was useful. Thank you.